Hello and welcome back. Today we are going to be going through the October-November 2020 paper for Pure Mathematics 1. So we have paper 12. Let's get started. Question number 1. The coefficient of x cubed in the expansion of 1 plus kx bracket 1 minus 2x to the power 5 is 20. Find the value of the constant k. So here we're going to be using the binomial expansion for 1 plus x to the power of n taken from the list of formula. So in this case we have 1 plus kx multiplying the terms in the second bracket, but for the second bracket we are only going to need the term in x squared and the term in x cubed so that we can get the term in x cubed for the expansion. So here we're going to be having the term in x squared as n of n minus 1 over 2 factorial. N is 5, so that will be 5 of 4 over 2 factorial. And that's x squared. In this case, x is minus 2x, so we have minus 2x squared. And that's plus n of n minus 1 of n minus 2 over 3 factorial, which is 5 of 4 of 3 over 3 factorial of x cubed. X is minus 2x, so that's minus 2x cubed. So this is what we have for the terms in x squared and the term in x cubed. Let's just continue simplifying. So we have 1 plus kx here, and it's multiplying 5 times 4, that's 20. 20 divided by 2 factorial. 2 factorial is 2. So we get 10 here. And 10 times minus 2 squared, which is 4. This is going to give us 40x squared. And then that's plus. And here we have 5 times 4 times 3, which is 60, divided by 3 factorial, which is 6. So we get 10 here. And 10 times minus 2 cubed, which is minus 8. We get minus 80. So it's minus 80 x cubed. So these are the terms in x squared and terms in x cubed in the binomial expansion of 1 minus 2x to the power of 5. So expanding, we are going to get, just looking for the terms in x cubed, we will have 1 multiply minus 80 x cubed, and we get minus 80 x cubed. So we're just saying here terms in x cubed, we will only have minus 80 x cubed, and kx will multiply 40 x squared, and that will give us plus 40 kx cubed. So that's the term in x cubed. And actually, if we can factor out x cubed, that's like minus 80 plus 40k is equal, bracket x cubed. So that's the term in x cubed in the binomial expansion for those two brackets. So what we can now do is, since according to the question they say that the coefficient of the term in x cubed is 20, I can now equate minus 80 plus 40k to 20. So that means that we have 40k here, and adding 80 to both sides we have 100. Then we can divide both sides by 40. So k comes out as a 100 over 40, which is 5 over 2. And that's the answer right here. That's the value of k. Question number 2. The first, second, and third terms of a geometric progression are 2p plus 6, minus 2p, and p plus 2 respectively, where p is positive. Find the sum to infinity of the progression. So what we're seeing here are consecutive terms of a geometric progression. And we know that if we divide a term by the one before it, we get the common ratio r. So Here we can make use of this to help us find the value of p by dividing minus 2p over 2p plus 6. This gives us the common ratio, which again is equal to p plus 2 over minus 2p, and this is also equal to the common ratio r. So let's simplify this and see if we can work out the value of p. Now minus 2p times minus 2p gives us 4p squared, and multiplying this 2, we get 2p plus 6 bracket p plus 2. So we can expand the bracket. That's going to be 2p squared plus 10p plus 12. Now, taking everything to one side, we'll be having 2p squared minus 10p minus 12 is equal to 0. And here we can factorize, and we get here 2p and p. Factorizing and factors of minus 12, most appropriate here will be 2 here and 6. So that's plus 2 and minus 6 here. Okay, so which means either 2p plus 2 is going to be equal to 0, or p minus 6 is going to be equal to 0. Here we get p coming out as minus 1, and here we get p coming out as 6. Now that we have two values of p, the one that we want, since according to the question, p is positive, so we are going to take p as 6. So this now means that we can now find the real value of the first term, which is a. So a will be 2p plus 6, which is 2 of 6 plus 6, and this gives us 18. And the real value of the common ratio r. Common ratio r is any one of this. That's minus 2p over 2p plus 6. So that's minus 2 of p, that's 6, over 2p plus 6, which is 18 here. So this gives us minus 2/3. So we can now work out the sum to infinity. We know that sum to infinity of a geometric progression is found by a over 1 minus r. So in this case here, the sum to infinity will be a, which is 18, divided by 1 minus r, which is minus 2/3 here. So this means that we'll be having, that's 18 divided by 1 plus 2/3 is 5 over 3. And dividing 18 by 5 over 3, we get 10.8. And this is our answer right here to question number 2. Question number 3. The equation of a curve is y is equal to 2x squared plus m bracket 2x plus 1, where m is a constant. And the equation of a line is y is equal to 6x plus 4. Show that for all values of m, the line intersects the curve at 2 distinct points. So what we're going to do first here is, I'm going to equate the two equations. That's the equation y is equal to 2x squared plus m of 2x plus 1 to y is equal to 6x plus 4. And we're going to rearrange this to get a combined quadratic equation. So we have 2x squared here, and m times 2x gives us 2mx, and m times 1 is m, but I'll take 6x and 4 to the left side, so that's minus 6x minus 4 is equal to 0. So I can have 2x squared here, and for the terms in x, that's 2m minus 6 of x, and the constants we have m minus 4, and that's all equal to 0. Now, what the question says is, we want to show that for all values of m, the line intersects the curve at 2 distinct points. Now, if the line intersects the curve at two distinct points, what we really want to show is the fact that b squared minus 4ac is greater than 0. This is what we want to show. So in this case here, a is equal to 2, b is equal to 2m minus 6, and c is equal to m minus 4. So let's perform the discriminant. So b squared minus 4ac, in this case that will be 2m minus 6 squared minus 4 of a, that's 2, and c, that's m minus 4. And let's simplify this. We get 4m squared minus 24m plus 36, and that's minus 8 times m, that's minus 8m, and minus 8 times minus 4, that's plus 32. And this gives us 4m squared and minus 24 minus 8, that's minus 32m, and 36 plus 32, this gives us 68. So we now have this expression for the discriminant in terms of m. So is this discriminant expression greater than 0 for all values of m? Well, to determine that, we can complete the square. So by completing the square, we factor out 4. So we have m squared minus 8m, and that's plus 17. And we complete the square, so that's m minus 4 squared, and that's minus 4 squared plus 17. So finally we get 4 of m minus 4 squared, and here minus 16 plus 17 gives us 1, and multiply that by 4, that's plus 4. So we have thus completed the square here. Now this expression here for the discriminant is always going to be positive for all values of m, because m minus 4 here is a square, so it's always going to be positive. So 4 times a positive number plus another a positive number here, which is 4, is always going to give us something that is greater than 0. So we can say this is always greater than 0 for all values of m. And therefore we can conclude, hence the line should intersect the curve at two distinct points. So that's how we would show it. Question number 4. The sum S sub n of the first n terms of an arithmetic progression is given by Sn is equal to n squared plus 4n. The kth term in the progression is greater than 200. Find the smallest possible value of k. So here we've got an expression for the sum of terms of an AP. So I can find here S1, which is the first term. So that's 1 squared plus 4 of 1, and this gives me 5. I can also find S2, which is just the sum of the first two terms. So that's 2 squared plus 4 of 2, and that gives me 12. And this means that I can actually say the first term of this AP is 5, and I can also find the second term. Second term here will be S2 minus S1, and that's 12 minus 5, and that's 7. So the second term will help me find the common difference, D, where I'm going to subtract the second term minus the first one. So that's 7 minus 5, and that's 2. So we now have the first term as 5 and the common difference as 2. So for the kth term, we know that the nth term of an AP is this. Un is equal to a plus n minus 1d. So for the kth term, this will be a plus k minus 1d. But from the question here, they say that the kth term is greater than 200. So we're going to say a, which is 5, so that's 5, plus d is 2, so 2 of k minus 1 is greater than 200. So let's simplify this. This means that we'll be having, subtracting 5 from both sides. On the left side, we're left with 2k minus 2, and that's greater than 195. And if we add 2 to both sides, that's 2k is greater than 197. And divide both sides by 2, then k is greater than 98.5. Now, what we want here is the smallest possible value of k, and the smallest possible value of k, that's the least integer value greater than 98.5, should come out as 99. So the value of k that we're looking for is 99, and that's the answer right here. Question number 5. The functions f and g are defined by f of x is equal to 4x minus 2, for x is an element of all real numbers, and g of x is equal to 4 over x plus 1, for x is an element of all real numbers and x is not equal to minus 1. So on A, find the value of f g of 7. So here we can start with g of 7, and g of 7 is 4 over 7 plus 1, which is 8. So that's a half. So when we now say f of g of 7, it's like we're saying 4 of g of 7, which is a half, minus 2. So this should be 2 into this gets into this 2 times, and 2 minus 2 is 0. So we get fg of 7 coming out as 0. Let's go on to part B. Find the values of x for which f inverse of x is equal to g inverse of x. Let's start with finding f inverse of x. So y is equal to 4x minus 2, and we make x subject, so x is equal to y plus 2 over 4, and therefore this translates to the inverse, coming out as x plus 2 over 4. We can do the same for g inverse. So we say y is equal to, the function g is 4 over x plus 1. So we make x subject. So that's multiplying, that's xy plus y is equal to 4. And thus xy is equal to 4 minus y. So that means that x is equal to 4 minus y over y. And if we interchange the variables, eventually we'll get g inverse of x coming out as 4 minus x over x. So we can now equate. So that's x plus 2 over 4 is equal to 4 minus x over x. Cross multiplying, we get x squared plus 2x, and on the right side we've got 16 minus 4x, and bring everything to one side, we'll be having x squared plus 6x minus 16 is equal to 0. And factorizing, we have x here and we have x here, and we'll be having plus 8 and minus 2, which means that either x plus 8 is the one that's equal to 0, or x minus 2 is the one equal to 0. So x comes out as minus 8 and x comes out as 2. And these two here are the two solutions to this problem. Question number 6. On part A, prove the identity 1 over cos x minus tan x multiplying 1 over sin x plus 1 is identical to 1 over tan x. So for this identity, I'm going to work with the left-hand side. And for the left-hand side, I have 1 over cos x minus, and in place of tan x, I'll use the identity, which is sin x over cos x. And that's multiplying 1 over sin x plus 1. So now I will expand the brackets. So the first terms, 1 over cos x times 1 over sin x, we get 1 over cos x sin x. And then I'll multiply minus sin x over cos x times 1 over sin x. And this is going to give us minus 1 over cos x. The outside terms, I have 1 over cos x times 1. So that will give me 1 over cos x. So this gives me 1 over cos x. And then lastly, minus sin x over cos x times 1. That's minus sin x over cos x. So this is what we now have. Now we know that minus 1 over cos x plus 1 over cos x gives us 0. So we cancel this out. So we're now left with the 2 here. And they have a common denominator, which is cos x sin x. So cos x sin x into cos x sin x, we just get 1. And cos x into cos x sin x, we get sin x. And multiplying this by sin x on top, we get minus sin squared x. Now this is equal to 1 minus sin squared x is actually cos squared x. So it's cos squared x divided by cos x sin x. And what does this give us? Now this cos x and this cos x divide, and we're left at the top with cos x over sin x, which is the inverse of tan x. So this is equal to 1 over tan x, which is equal to the right hand side, hence proved. Let's go to part B. Hence solve the equation 1 over cos x minus tan x bracket 1 over sin x plus 1 is equal to 2 tan squared x for 0 to 180 degrees. Now we've already gotten the identity for 1 over cos x minus tan x bracket 1 over sin x plus 1, and from part A this is 1 over tan x. So we know that this whole thing here is 1 over tan x. This whole thing here is 1 over tan x. So it's more like we're saying 1 over tan x is equal to 2 tan squared x. And if we multiply both sides by tan x, it means that we'll come out with 2 tan cubed x is equal to 1. Which means tan cubed x is equal to a half, which means tan x is equal to 1 over the cube root of 2 if we are going to cube root both sides. So we can now work out for x to say that x is equal to arctan of 1 over cube root of 2. We need a calculator for this. So we're saying this is shift tan of 1 over cube root of 2, and this is giving us 38.4 degrees. So x is 38.4 degrees. So this is the first value, and this should be the only value of x that is within the range from 0 to 180 degrees. So our answer comes out as x is equal to 38.4. Question number 7. The point 47 lies on the curve y is equal to f of x, and it is given that f prime of x is equal to 6 to the minus half minus 4x to the minus 3 over 2. So on A, a point moves along the curve in such a way that the x coordinate is increasing at a constant rate of 0.12 units per second. Find the rate of increase of the y coordinate when x is equal to 4. So here we're going to use the chain rule. They want us to find the rate of increase of the y coordinate. So we're actually looking for dy by dt, and the chain rule is dy by dx times dx by dt. Now what is dy by dx? We have the derivative already here, f prime of x, which is 6x to the minus a half minus 4x to the minus 3 over 2. Okay, so we're going to have that, but remember x is equal to 4, so that is going to be 6 of 4 to the minus a half minus 4 of 4 to the minus 3 over 2, and then that's times dx by dt. Now this is the part where they say the x coordinate is increasing at a constant rate of this, so this is dx by dt. So dx by dt is 0.12. So we multiply this by 0.12. So let's simplify this a little bit more. Now here, 6 times 4 to the minus to the power of minus a half. 4 to the power of minus a half is like 1 over 2. So 6 times a half, that's 3, minus 4 off. Here, 4 to the power of minus 3 over 2, that's half cubed, that's an eighth. So this should be an eighth, and that's times 0.12. Now 3 minus 4 times an eighth, which is a half. 3 minus a half is 2.5. So we're actually looking for 2.5 times 0.12, and that's 2.5 times 0.12, that's 0.3. So we get 0.3 here, and that's the rate units per second. And that's how we do it for part A. Let's go to part B. Find the equation of the curve. Now to find the equation of the curve, we are going to integrate, because we already have here the gradient function f prime of x. So let's take the gradient function here. So we have it here. So to get the equation of the curve, that's y, we are going to integrate this. So that will be the integral of 6x to the minus a half minus 4x to the minus 3 over 2 dx. So let's integrate. So this is going to be 6x to the minus a half plus 1, that's a half, and it's all divided by a half, that's minus. Here we'll be having 4x to the power of minus 3 over 2 plus 1, that's minus a half, so it's all divided by minus a half, and then that's plus c. So we can simplify this to 6 divided by a half, that's 12, so that's 12x to the power of a half, and this is going to be plus 4 over a half, that's 8, so that's 8x to the power minus of a half, and then that's plus c. But we do not know what c is yet, but what we know is that there's a point on the curve, which is the point 47. So we'll use the point 47 here, where we'll be saying when x is 4, y is 7. So therefore 7 is equal to 12 of 4 to the power of a half plus 8 of 4 to the power of minus a half plus c. So that 7 is equal to 4 to the power of a half, that's 2. 12 times 2, that's 24. And 4 to the power minus a half, that's a half times 8, that's 4, and that's plus c. So 7 is equal to 24 plus 4, that's 28 plus c. So this gives us c coming out as minus 21. So if c is minus 21, it therefore means that the equation of the curve will come out as y is equal to 12x to the power of a half plus 8x to the power of minus a half plus c, which is minus 21. This is the answer right here. Question number 8. In the diagram, ABC is an isosceles triangle with AB equal to BC equal to r centimeters and angle BAC is equal to theta radians. The point D lies on AC and ABD is a sector of a circle with center A. So on A, express the area of the shaded region in terms of r and theta. Now, in order for us to find the shaded area, we are saying that this should be equal to the area of the triangle ABC. So it's area of triangle, and that's minus the area of the sector. This is sector ABD. So it's minus area of sector. Now for the area of the triangle, we're gonna use the formula half times side sine the included angle. Now the angle here is actually pi minus 2 theta, and the reason for that is this triangle is isosceles since AB is equal to BC. So this angle here, which is the best angle, should be theta radians in size. So for the third angle, we'll be saying it's pi minus the sum of the two angles, which is pi minus 2 theta. So for the area of the triangle, that's half times r times sine of the angle pi minus 2 theta. And that's going to be minus the area of the sector ABD. And for area of sector, it's half times the radius squared. So it's half r squared times the angle. And in this case, we're talking about the angle theta. So we can simplify this a bit. And this is going to give us, that's half of r times r, which is r squared, of sine of pi minus 2 theta. Now sine of pi minus 2 theta is the same as sine of 2 theta. And that's minus half r squared theta. So we can have our answer like this. Let's go on to part B. It says, in the case where r is equal to 10 and theta is equal to 0.6, find the perimeter of the shaded region. Okay, so here we've got the shape. Now, the perimeter P is going to be equal to the arc BD plus the line BC plus DC. So let's see how we can find all these. We start with BD. BD is the arc from sector ABD, and for length of arc we use the formula r theta, and r is 10, so that will just be 10 times theta, which is 0.6, and that's plus. For BC, BC is r, so r is 10, so that's just plus 10. Then DC, DC is this part here, and to find DC we have to subtract AC minus AD. Now AC here is twice this length, of which for this length here we can use the trig ratio cos to say that this is equal to r cos theta, which means AC is 2r cos theta, and we know that r is 10, so that's 2 of 10 of cos of 0.6, which is 20 cos 0.6. So we know that AC is that, so we are going to say DC is 20 cos 0.6, and that's minus AD, of which we know that AD is equal to R, and that's 10. So this is what we are going to use to calculate the perimeter P. So let's do that. So for my calculator, I'll type in 10 times 0.6, we know that's 6, and then that's plus 10, then that's 20 cos 0.6, so 20 cos 0.6, and then that's minus 10, and this is giving us 22.5 to 3SF. So we get 22.5 centimeters as the perimeter of the shaded region. Question number 9. A circle has center at the point B with coordinates 5, 1. The point A with coordinates -1 and -2 lies on the circle. So on A, find the equation of the circle. Now here we've got a circle with center B and the point A on the circumference of the circle. So in order for us to find the equation of the circle as required, we'll first need to work out the radius of the circle. It would be good if we can work out the radius squared, which will be AB squared, and that will be 5 minus -1 squared plus 1 minus -2 squared, and we can simplify this, and this is 5 minus -1, that's 6, and 6 squared is 36, and that's plus 1 minus -2 is 3, 3 squared is 9, so 36 plus 9 is 45, so this is AB squared, and that's the radius squared. So for the equation of the circle, using the coordinates of the center B, it will come out as x minus 5 squared plus y minus 1 squared is equal to the radius squared, which is 45. So this here is the answer, the equation of the circle. Let's go on to part B. The point C is such that AC is the diameter of the circle. Point D has coordinates 5, 16. So on B, show that DC is a tangent to the circle. So from the information given, there's another point C, which should be somewhere here, such that AC is the diameter of the circle. So here with the information we have, we can work out for the coordinates of C. So let's start with that. So for the coordinates of C, we can use the fact that the point B here is the midpoint of the line joining A and C. So if we say the coordinates of C are A and B, then if we add the x coordinate of C plus the x coordinate of A, which happens to be -1, and we divide that by 2, we should get the x coordinate of the midpoint, which is B, which happens to be 5. So here we can solve for A by multiplying both sides by 2 to get 10 here and adding 1 to both sides, which gives us A coming out as 11. We can also add the y coordinates. That's the y coordinate of C, which we said can be represented by B, plus the y coordinate of A, which is -2. Divide this 2 by 2 and say this is equal to the y coordinate of the midpoint B, which is 1. So multiply both sides by 2, that's 2, and add 2 to both sides, we get B coming out as 4. So therefore, the coordinates of C are 11 and 4. So now that we know what the coordinates of C are, we want to prove that DC is a tangent to the circle. So let's work out for the gradient of DC. So gradient of DC. Now the point D, we have it here. The coordinates are 5, 16. And C is the point that we got the coordinates to be 11, 4. So changing y over changing x, that will be 16 minus 4 divided by 5 minus 11. 16 minus 4 is 12. And 5 minus 11 is minus 6. And therefore, the gradient of DC comes out as minus 2. So we now know the gradient of the line that we want to prove, that is a tangent to the circle. Let's also work out the gradient of AC, which is the diameter to the circle. So gradient of AC. So we're using the point A, which has coordinates minus 1 and minus 2, and C with coordinates 11, 4. So changing y over changing x. So we are saying here minus 2 minus 4 divided by minus 1 minus 11. This will give us minus 6 over minus 12, and this comes out as a half. So we now have the gradient of the diameter. Now, to show that DC is a tangent, or to determine whether DC is a tangent, we have to do the product of the gradient of DC itself and the gradient of the diameter, which is AC. And multiplying the two, we have minus 2 multiplying a half, and this gives us minus 1. And coming out with the product as minus 1 tells us that the line DC is definitely a tangent to the circle, because a tangent should be perpendicular to the diameter at their point of contact. So we've proved that they are perpendicular, and hence DC is a tangent. So that's how we show it. Let's go to part C. It says the other tangent from D to the circle touches the circle at E. So on C, find the coordinates of E. So we have right here the point D, which from part B we had shown that the line DC is a tangent to the circle. And according to this question, there's another tangent from D, which is touching the circle at E. So we want to find the coordinates of E. Now we're going to use the fact that, if you notice, the x-coordinate of D, which is 5, is the same as the x-coordinate of the center B. And what this tells us is that D and B are on the same vertical line, which happens to be a line of symmetry for DC and DE. So if we use the concept of symmetry, knowing that the gradient of DC came out to be minus 2, so by symmetry, the gradient of DE should come out as 2. So having known the gradient of DE, we can work out the equation of DE, because finding the equation of DE will help us find the coordinates of E. So for the equation of DE, we're going to use y minus y1 is equal to m of x minus x1. Now, the point that we're going to use is the point D with coordinates 5, 16. So that's y minus y1, which is 16, is equal to 2 of x minus 5. So we can simplify this to get y coming out as 2x plus 6 if we add 16 to both sides. So we now have the equation of DE right here. Now with the equation of DE and also knowing the equation of the circle, the equation of the circle came out as x minus 5 squared plus y minus 1 squared is equal to 45. You see how at point E, the line touches the circle once. So we're gonna solve these two equations simultaneously, and this will help us to find the coordinates of their point of contact, which is E. So let's do that. So I'll write down equation 2. And for equation 2, I'm going to substitute equation 1 into it, which means equation 2, which is the equation of the circle, will come out as x minus 5 squared plus y, but in place of y, I'll put 2x plus 6. So that will be 2x plus 6 minus 1, which is 2x plus 5. And that's all squared is equal to 45. So let's simplify this. This is x squared minus 10x plus 25. And this one is 4x squared plus 20x plus 25. And the 45, I'll take it to the left side. So that's minus 45 is equal to 0. X squared plus 4x squared is 5x squared. Minus 10x plus 20x, that's 10x. So I'll write the 10x here. 25 plus 25, 50. Minus 45, that's 5. So that's plus 5 equal to 0. So 5, factoring it out, is x squared plus 2x plus 1 equal to 0. So again, we can factorize this, and we are going to get x plus 1 here. So we can say that x comes out as minus 1 twice. So the x coordinate of E is minus 1. Then how about the y coordinate? We will need equation 1 for that. Equation 1 is y is equal to 2x plus 6. So that's y is equal to 2 of minus 1 plus 6, which is minus 2 plus 6, that's 4. So the y coordinate is 4. So we have the x coordinate is minus 1 and the y coordinate is 4. So the coordinates of E should come out as minus 1 and 4. And this here becomes the final answer. Question number 10. The diagram shows part of the curve y is equal to 2 over 3 minus 2x to the power 2 minus x, and its minimum point M, which lies on the x-axis. So on A, find expressions for dy by dx, d squared y by dx squared, and the integral of y with respect to x. So let's work this one out. So I'll write down the equation of the curve is y is equal to 2 of 3 minus 2x to the power of minus 2 minus x, which means that I can find dy by dx, and for dy by dx, I'll take the 2, then bring down the minus 2, then differentiate inside the bracket to get minus 2. Then I write down the 3 minus 2x to the power of minus 2 minus 1. And differentiating minus x, we get minus 1. So this can be simplified to 2 times minus 2 times minus 2 is 8. So we have an 8 of 3 minus 2x to the power of minus 3 minus 1. So this is what we get here for dy by dx. Let's move on to the second derivative, that's d squared y by dx squared. So d squared y by dx squared, we'll be saying here we are differentiating the first derivative. So we have the 8, then we bring down the minus 3, then we differentiate inside the bracket to get minus 2, then we have the 3 minus 2x, and that's to the power of minus 3 minus 1. And if we differentiate minus 1, we get 0. So 8 times minus 3 times minus 2 gives us 48. So we have 48 here. And that's 3 minus 2x to the power of minus 4. So this becomes the answer for d squared y by dx squared. And lastly, let's go on to the integral of y with respect to x. So let's do that. So we're saying here, the integral of y with respect to x, differentiating y here, it means that we will get 2 of 3 minus 2x to the power of minus 2 plus 1. And that's over here. Inside the bracket, we take minus 2. And that's times minus 2 plus 1. And then integrating minus x, we get minus x squared over 2. And that's plus c. So we can simplify this too. That's 2 of 3 minus 2x to the power of minus 1. And that's over minus 2 times minus 2 plus 1 is minus 1. So minus 2 times minus 1 is 2. And that's minus x squared plus, over 2 plus c. Finally, it comes out to be, we cancel those 2 out. That's 3 minus 2x to the minus 1 minus x squared over 2, and that's plus c. So this is the answer right here for the integral of y with respect to x. So that's how we do it. Let's move on to part B. Find by calculation the x coordinate of M. Now if we go back to the graph, M is the minimum point, so it's a stationary point. And we know that for stationary points, dy by dx should be equal to 0. So we're going to take what we got for dy by dx and equate it to 0. So I'm going to say here, at M, dy by dx is equal to 0. And dy by dx, we had gotten it as 8 of 3 minus 2x power minus 3 minus 1. So it's equal to 0. I'm going to add 1 to both sides and divide both sides by 8. So on the right side, I'll be having an 1/8. On the left side, I'll be left with 3 minus 2x to the power minus 3, which is as good as 1 over 3 minus 2x to the power of 3. So I'll cross multiply here so that we get 3 minus 2x to the power of 3 is equal to 8. Now, if I cube root both sides, it means I'll be left with 3 minus 2x on the left side, and the cube root of 8 is 2. So we can now solve for x. So I have minus 2x here, and I'll subtract 3 from both sides. So I get 2 minus 3, which is minus 1, and then divide both sides by minus 2 to get x coming out as a half. So the x coordinate of M is coming out as a half, and that's the answer to part B. Let's move on to part C. Find the area of the shaded region bounded by the curve and the coordinate axis. So we want to find the area of the shaded region here. To get the area, we're going to use the limits from 0 up to the x coordinate of M. We had already integrated y with respect to x, so our job is half done. So we're just going to say the area of the shaded region is found by the integral from 0 to a half of y with respect to x. Now we'd already integrated y with respect to x, and that was in part A. And what we got for the integral of y with respect to x was 3 minus 2x to the minus 1 minus x squared over 2 plus c, but we don't need the constant of integration here. So we'll just take that. So that's 3 minus 2x to the power of minus 1 minus x squared over 2. And we put in the limits, that's from 0 up to a half. So we now be saying here, substituting a half in place of x, here we'll be having 3 minus 2 times a half. That's 3 minus 1, so that's 2. And 2 to the power of minus 1 is a half. And that's minus, substituting a half here. So that would be minus a half squared, which is a quarter, divided by 2. That's 1 over 8. And then if we substitute 0 into this whole thing, we'll be having here, this becomes 0. So 3 to the power minus 1 is a third. And that's minus, this whole thing becomes 0. So we have half minus an eighth minus a third. And what we get here is 1 over 24. So this is the value of the area of the region bounded by the curve and the coordinate axis. It comes out as 1 over 24. Question number 11. A curve has equation y is equal to 3 cos 2x plus 2 for values of x between 0 and pi. So on A, find the greatest and least values of y. So here we know that for the graph of y is equal to cos 2x, y values range from a minimum of minus 1 to 1. So when we now have 3 cos 2x plus 2, it means that we'll be multiplying the limits by 3 and adding 2 to them. So here for the least value of y, we are just going to say that's 3 of minus 1, which is the lower limit, plus 2, and that's minus 3 plus 2, we get minus 1. And for the greatest value, we'll be saying 3 of 1, and that's plus 2, and in this case we get 5. So these are the least and greatest values right here. Let's move on to part B. Sketch the graph of y is equal to 3 cos 2x plus 2 for values of x between 0 and pi. So for this one, there are many different methods that you can use to make the sketch. But here I would want to do it this way. I'm going to take the equation of the graph, which is y is equal to 3 cos 2x plus 2. So here, the idea is to take the 2x here, representing the angle, and equate it to pi over 2. So that we get x coming out as pi over 4. Which means that I'll be having on my graph increments of pi over 4 on the x-axis. So I'm now drawing the axis for the graph. This is the vertical axis, and this is the horizontal axis. The origin is here. So my increments on the x-axis are going to be pi over 4 increments. So from 0, I have the equal intervals here. This is 0, and this is going to be pi over 4. This is going to be 2 of pi over 4, which is pi over 2. This is going to be 3 of pi over 4, which is 3 pi over 4. This is going to be 4 of pi over 4, which is pi. So we end here, since according to the question, the range of x values is from 0 to pi. Now for these x values here, I'm going to find the corresponding y values using the equation of the graph. I'll have here a small table of values, and I'll say this is x and this is y. And for x, we've got 0 and pi over 4 and pi over 2 and 3 pi over 4 and pi. For the y values, we can simply substitute them into the equation of y, and we're going to get, when x is equal to 0, y comes out as a 5, and when x is pi over 4, we get 2 here. When x is pi over 2, y is minus 1. When x is 3 pi over 4, y comes out as a 2, and when x is equal to pi, then y comes back to be a 5. So let's put these points on the graph. So we're saying here, when x is equal to 0, y is 5. So we can have, say, 5 around here. Let's say this is 1, 2, 3, 4, then 5. And now when x is pi over 4, y is 2. So let's go on to 2. So this is 1 and this is 2, 3, 4. So when x is pi over 4, y is 2. So somewhere around here. Then when x is pi over 2, y is minus 1. So we can have minus 1, say around here, which means the point here will be somewhere down here. Then we also have when x is 3 pi over 4, y is 2. So the point will be somewhere around here. Lastly, when x is pi, y is 5. So we go back to 5. So we can plot the graph and it should come out something like this. It's just a sketch, so just try to make it good. So this is the graph that we get here for y is equal to 3 cos 2x plus 2. Okay, let's go on to part C. By considering the straight line y is equal to kx, where k is a constant, state the number of solutions of the equation 3 cos 2x plus 2 is equal to kx for values of x between 0 and pi in each of the following cases. So number 1, that's when k is equal to minus 3. So here when k is equal to minus 3, it means we want to find the number of intercepts between the graph of y is equal to minus 3x, because k is minus 3, and the curve y is equal to 3 cos 2x plus 2. So let's start with this line, y is equal to minus 3x. So if we consider y is equal to minus 3x, it's going to come through the origin and it has a gradient of minus 3. So let's find another point that we can make use of. Let's say when x is equal to pi over 4, then what is y? So we can simply do that by multiplying minus 3 times pi over 4. So that will be minus 3 pi over 4. And using our calculator, 3 pi over 4 is 2.356. So minus 3 pi over 4 should be minus 2 point. If this is minus 2, so it has to be somewhere down here, just below minus 2, which means the line should come out to be somehow like this. And I think you can see that this line can never come into contact with the curve for the given range. So we can say here that there is 0 solution. Now let us look for the situation when k is equal to 1, which means we want to find the number of roots for the intersection of the graph y is equal to 1x, which is x, and the curve y is equal to 3 cos 2x plus 2. So let's again take a look at that. Now the line y is equal to x will also come through the origin, and when x is equal to pi over 4, y should also be pi over 4 since y is equal to x. Pi over 4 is 0.785, like 0.79, and 0.79 is just below 1, so it could be somewhere around here. And if we are going to make a sketch of the line, it should certainly be a line coming out like this. And I think you can see that it's intercepting the graph at 2 points, which shows us that there are 2 solutions here. So we can say 2 solutions. Then lastly, when k is equal to 3, it means we're talking about the line y is equal to 3x. And for y is equal to 3x, we know that when x is equal to, say, pi over 4, y should be 3 pi over 4, and we'd gotten 3 pi over 4 from our previous calculation to be 2.35. So 2.35 is just above 2. So when x is pi over 4, that will be just around here. And if we are going to draw a line just by our own analysis, we find that it will go this way. And it is simply going to intersect the graph only once at this point here, which means that we can say that we only have one solution. So that's how we do it for part C. Let's go down to part D. The functions f, g, and h are defined for x is an element of all real numbers by, and we have here f of x, g of x, and h of x. So on D, they say describe fully a sequence of transformations that maps the graph of y is equal to f of x to the graph of y is equal to g of x. So we're talking about f of x to g of x. So g of x is f of 2x plus 4. That's f of 2x plus 4. Now when you have a constant inside the bracket here, multiplying x for the function f, it means we're talking about a stretch parallel to the x-axis, and the factor will be a half. And when you have a plus 4 here, this is mainly going to be a translation parallel to the y-axis of factor 4. So let's write that down. First transformation is a stretch of factor a half, and that's parallel to the x-axis. So that's the first transformation, and the second transformation is going to be a translation in the y direction by 4 units. So these are the two transformations for f of x being mapped onto y is equal to g of x. Then on part E, describe fully a sequence of transformations that maps the graph of y is equal to f of x onto y is equal to h of x. So here we've got f of x getting on to h of x. Now for 2 of f of x plus pi over 2 or half pi, let's write that down. 2 of f of x plus half pi. The two transformations happening here, the 2 on f means we're talking about a stretch parallel to the y-axis with factor 2, and the half pi here means we're talking about a translation parallel to the x-axis by minus half pi units. Okay, so let's write that down. We start number 1 inside the bracket, so that's a translation in the x direction by negative half pi units. And then we go outside then with the 2, so that's a stretch by a factor of 2 parallel to y-axis. And these are the two transformations right here. And that, my friends, concludes the paper. Thank you for watching.